Hey guys, in today's video, you'll learn how to build your GraphQL server with Node.js and Apollo Server. We will define schema types, write queries, and implement resolvers. And then I will show you how to test your new API using the Apollo Sandbox. Let's get started. We have our GraphQL server folder open in VS Code. The first thing we need to do is initialize our Node.js project. Let's open the terminal and run npm init-y. Now we have the package.json file for our Node.js project. Let's modify this type CommonJS2 module. We will be using latest AS module throughout the server. Now let's install necessary packages, that is Apollo Server and also GraphQL. This will let us create a GraphQL server, define a schema, and execute queries over HTTP. We are also able to view it in package.json. Then simply create index.js file. Next, import the Apollo server from @Apollo server. This is what we will use to set up the GraphQL server. Also import start standalone server from Apollo server standalone. This starts the server and exposes our GraphQL endpoint. Apollo server is an open source GraphQL server that lets us define a schema, write resolvers, and expose a single HTTP endpoint that parses, validates, and executes GraphQL operations. Now create an Apollo server instance with your type definitions and resolvers. Your type diffs define the schema, types and fields, and resolvers are the functions that return the data for those fields. We will add a fuller schema later. For now, let's use start standalone server to listen on a port like 4000. We can also console this URL. Let's also install Nodemon. Then in the package.json include start and it will hold a Nodemon index.js. Now let's move on to the type definitions. I have already covered the basics of GraphQL types and queries in an earlier video. The link is in the description. For the schema, create a file named schema.js. Inside it, define the schema using a tag template string with the #GraphQL tag. This tag helps tools recognize and validate the schema definition language inside the backticks. Now initialize the user type with its fields and data types. We can also include int for the age and boolean for the is verified field. Then declare the query type that exposes our read operations. This part returns a non-null list of non-null user objects, that is always an array with no null items. In this user ID part, user fetches a single user by a required ID and returns a user or null if not found. Here both fields reference user. They depend on the user type being defined. That's how the schema ties the entry points query to the shape of data that is user. We need to include these type definitions to Apollo server. For that, we can just import the type definitions from our recently created schema. Since we are not using a database in this demo, we'll keep our data in a separate file. Let's create data.js. Here we will add a small array of users that match our user type. For this ID one, I will provide name to Steve. I will also provide dummy email. Similarly, let me complete for age and is verified also. Let's include 2 to 3 data. I will simply copy this and modify the values. Finally, we will provide data of David. So we have stored 3 different values of users in this file. To make our types return this data, we also need resolvers. First, let's understand what a resolver is. A resolver is a function that's responsible for populating the data for a single field in your schema. Here in the example, you can see the schema defines 2 fields on query, num6 with data type int and num7 also with int. The resolvers object then implements function for those fields, so they always return 6 and 7 when queried. That's the core idea. Each field in the schema maps to a function that returns its value. Back in our project, let's create resolver.js. We will be using resolver function for our root query. Inside this, first we need to include query. For users, we will return the array of users, which is all the users from the data.js file. So let's import this. And include it here. Since we are using arrow function, we don't need to explicitly set return. For user, we will return a single user by ID. The resolver receives parent and arguments. Since this is a root level field, we will ignore parent with an underscore and extract ID from args. Then simply find the matching user. So yeah, we have made our 2 resolver function for our all users and single user by ID. Now we can pass this resolver function to our Apollo server. It's already passed, we just need to import our resolver. Then we can finally run our project using Nodejs. I guess we got some issue in import. Yeah, for ESM module, we can't import file without including its .js extension. So simply include .js in these imports. We will also include in our resolver.js file for the data.js. Now there is no issue. You can see the message on the console that our server is ready at localhost 4000. So we can just copy this and open in our browser. Now we have our Apollo Sandbox. On the left, the schema panel shows the API schema that Sandbox introspects from the running server. It lists our root query fields like user and users. Clicking a field shows its return type, arguments, and the underlying user type with its field's data types. This makes it easy to browse the schema and understand exactly what each operation returns before writing a query. Now let's proceed on our query. Let's give our query an operation name getAllUsers. This is just a label for us to identify the query. We could name it anything, and below this we will be selecting the users. Now inside the curly braces, we specify which fields we want back on the users object. We can choose only the name and age of the users. After that, simply run this query. Then on the response, you can see we are able to fetch our provided field data of all users. We can also request all the fields available for the users. Doing so, we get all the fields in the response. Suppose if we request for the field that is not present in schema like nationality, then you can see we get the error cannot query this field. So Apollo lets clients request exactly the fields they need, single or multiple, and the solver returns only those fields as long as they are defined in the schema. Now that we have listed all the users, let's query a single user. I will open a tab and name this operation getUser. At the top, define a variable called $ID with the type ID. We declare this part so GraphQL can validate the argument type. Then call the user field and pass ID with the value $ID, where $ID is the variable declared for this operation. The $sign indicates a GraphQL variable, and GraphQL substitutes its runtime value from the variables panel when executing the query. Inside the braces, select the fields to return just like before. Pick only what's needed. For example, name, email, and is verified. Then in the variables, we need to pass the ID value. Let's get the data of Steve Rhodes. So it would be 1. Then let's execute this, and you can see we are able to get the name, email, and is verified for Steve. Similarly, we can also retrieve of David, which is the ID 3. If a non-existent ID is provided, the field simply resolves to null as the data for this ID doesn't exist. So we perfectly completed the individual user query also. There is now a clear understanding of the root queries for listing all users and fetching a single user by ID. Our next step is to model relationship between user and related types, exposing them as nested fields with the dedicated resolvers. Let's define the post type with its fields like ID, title, content, and include an author field that references the user who wrote it. This field is required. Then add a post field on the user to represent all posts authored by that user. Now since we have added the relation, we also need to add in our resolver function. But before that, we need to also add some fields in our data.js. Currently there is only user data. So create a post array with each post ID, title, content, and an author ID that links the post to its author. The author ID serves as the foreign key that the resolvers use to connect post author and user post. For this post also, we will be using same author ID as of our first data. That means multiple posts can share the same author ID, linking them to the same user Steve in a one-to-many relationship. Finally, for the third post, I will be using different author ID. Now that the user and post data are in place, proceed to the resolvers to wire up the root queries and the nested relationships. Then let's import our post collection. Let's look at our query resolvers. We have a user query that takes an ID and returns a single user. This works perfectly for fetching user details, but what if we want to get that user and all the posts they have returned? Right now our root user resolver only knows about the ID argument. It has no information about the post a client might be asking for. It can't return a user's post because its job is just to find that one user. That is why we don't put relationship logic in the root query resolver. Instead, we create a new object user. Inside this, we can create a resolver function post. This function receives the parent user object. That means this user function runs, finds the user with ID and returns that complete user object. That returned object is then passed down as the parent. Finally, our resolver function uses its ID to filter the post collection, returning only the posts where the author ID matches. So here we are comparing the author ID with the parent ID, which is the user ID. This is how GraphQL resolves the post field whenever you query for a user and include their posts. Similarly, on the post type, we add an author resolver. This function receives the parent post object, takes its author ID, and finds the matching user in our users collection. This allows any query for a post to also fetch the author's details. Now let's go back to our Apollo Sandbox. In the next tab, we can just copy this get user and I will simply change the query name user post. We have already the field for user. Let's add for the post also. I am gonna include the title and content. Then provide the ID in the input variables. And you can see for ID 1, we have two posts in the response for a single author Steve. GraphQL and Resolver had the same author ID. Similarly, we can also get the post for ID too. Finally, for the ID 3, there is no any post, so it returns empty array. We have successfully written nested posts associated with that author. Now let's flip it around. What if we want to start with the post and find its author? I can name this query to post and author. And let's provide the post fields, and inside it the author field. When we run this, you can see the response is an error, that is cannot query field post on the type query. It's because our GraphQL schema, which is the rulebook for our API, doesn't have an entry point named post in the root query type. We have defined how to get from a user to their post, but we haven't defined how to jump directly to a single post. To fix this, we need to add a post field to our query type in the schema. And then provide a corresponding resolver function that knows how to find a post by its ID. It's similar to find user by ID. This will create the new entry point our query needs to work. Now you can see the response. We have single author associated with that post. Similarly, for ID2 also the author is the same. For ID3 we are getting the author Zach. So that's all for related data with nested structure. In this tutorial, we successfully built a GraphQL server from scratch using Nodejs and Apollo Server. We defined our schema with user and post types, implemented root queries to fetch lists and single items, and most importantly, we wired up the relationships between them using nested field resolvers. Thank you guys for watching this video.